The world's most advanced passenger airplane doesn't begin its life in the sky. It begins as thousands of separate parts arriving from different continents, each one built with incredible precision. Then, inside one of the largest factories ever constructed, those parts slowly come together to create an aircraft worth nearly $400 million. But building a Boeing 787 Dreamliner is far more than simply putting pieces together. It is one of the most complex manufacturing processes on Earth. Today, we're taking you inside the world's largest airplane factory to see exactly how this engineering masterpiece is built from the ground up. Before we step inside this incredible factory, make sure to like this video and subscribe to the channel. We bring you the world's biggest factories, amazing engineering projects, and the full manufacturing process behind the machines that shape our future. Now, let's go behind the scenes of one of the most fascinating production lines in aviation. Every Boeing 787 begins long before it reaches the final assembly building. Unlike traditional airplanes that are built almost entirely in one location, the Dreamliner is the result of a truly global manufacturing network. Major sections of the aircraft are designed and produced in different countries, each specializing in a specific part of the airplane. Huge fuselage sections, advanced wings, landing gear, engines, electronics, and thousands of other components are manufactured separately before beginning an incredible journey toward the final assembly factory. Transporting these giant sections is an engineering challenge by itself. Standard cargo aircraft simply cannot carry components this large. To solve the problem, Boeing developed one of the world's most unusual transport airplanes. Known as the Dreamlifter, this modified aircraft has an enormous cargo compartment capable of carrying complete fuselage sections and massive wing components across the globe. Every flight saves valuable production time by delivering critical parts directly to the assembly line. As these oversized components arrive at the factory, they undergo detailed inspections before entering production. Engineers carefully examine every section using laser measuring systems, digital scanners, and precision inspection tools. Even the smallest manufacturing error can affect how thousands of parts fit together later in the process. Every measurement must be accurate within incredibly small tolerances before assembly can begin. Walking inside the final assembly building feels almost unreal. The factory stretches across an area so large that several football stadiums could fit inside. Towering cranes move silently above the production floor, while engineers, technicians, and robotic systems work together below. Despite the enormous size of the building, every movement follows a carefully planned schedule where thousands of individual tasks must happen at exactly the right time. The first major step begins with joining the giant fuselage sections. Unlike older aircraft that are built from countless aluminum panels connected by thousands of rivets, the Boeing 787 uses large carbon fiber composite barrels. These advanced sections arrive almost completely finished, dramatically reducing assembly time while creating a lighter and stronger airframe. Massive automated positioning systems slowly move each fuselage section into place. Powerful laser alignment equipment checks every angle before the sections are connected. The process may appear slow, but precision is everything. A tiny misalignment at this stage could create serious problems later when installing the wings, doors, or internal systems. Engineers verify every measurement again and again before giving approval to continue. Once the fuselage becomes one complete structure, attention shifts to the aircraft's enormous wings. The Dreamliner features one of the most advanced wing designs ever built for commercial aviation. Unlike traditional aluminum wings, these are made almost entirely from carbon fiber composites. This material provides exceptional strength while remaining significantly lighter than metal, helping reduce fuel consumption during every flight. Installing the wings requires incredible accuracy. Giant cranes carefully lift each wing, while engineers guide it into position using digital alignment systems. Specialized tools secure the connection between the wings and fuselage with extraordinary precision. Although the entire operation looks effortless from a distance, hundreds of calculations and inspections take place behind the scenes to ensure the structure can safely withstand millions of flight cycles. Next comes one of the busiest stages inside the factory. Thousands of electrical cables begin making their way through the aircraft. If stretched end to end, the wiring inside a single Dreamliner would extend for well over 100 miles. Every cable has a specific location, carefully routed through narrow spaces inside the aircraft structure. Technicians follow detailed digital instructions to ensure every connection is installed correctly. Alongside the electrical systems, workers begin installing hydraulic lines, fuel pipes, oxygen systems, environmental controls, and hundreds of electronic components. Modern passenger aircraft are essentially flying computer networks. Thousands of sensors constantly monitor the engines, cabin pressure, fuel systems, electrical power, and flight controls. Every one of these systems must communicate perfectly before the airplane can ever leave the ground. The cockpit slowly transforms from an empty shell into one of the most advanced flight decks in commercial aviation. Large digital displays replace the traditional collection of analog instruments found in older aircraft. Sophisticated flight computers, communication systems, navigation equipment, and automated controls are carefully installed one component at a time. Every switch, screen, and control is tested repeatedly before power is ever applied. Meanwhile, another team works inside the passenger cabin. The empty interior gradually becomes recognizable as a modern airliner. Insulation panels cover the aircraft structure before sidewalls, ceilings, overhead bins, lighting systems, and flooring are installed. Depending on the airline placing the order, each cabin receives its own customized layout with different seating arrangements, premium cabins, galleys, and entertainment systems. One of the Dreamliner's biggest innovations is passenger comfort. Unlike many older aircraft, the cabin is designed with larger windows, improved humidity levels, quieter engines, and higher cabin pressure. These features help reduce passenger fatigue during long international flights. While travelers may simply notice a more comfortable experience, achieving these improvements required years of engineering research and countless manufacturing innovations. Outside the aircraft, another incredible operation is taking place. The massive engines arrive separately from specialized engine manufacturers. Each engine costs tens of millions of dollars and contains thousands of precisely engineered components. Despite weighing several tons, the engines must be installed with extreme accuracy because they become one of the most critical parts of the entire aircraft. Using powerful lifting systems, technicians carefully position each engine beneath the wings. Every mounting point is inspected before hydraulic, electrical, fuel, and digital control systems are connected. Modern jet engines generate enormous amounts of thrust while operating under extreme temperatures, making perfect installation absolutely essential for both performance and safety. But even after the engine's wings, cockpit, and passenger cabin are fully installed, the Dreamliner is still far from ready for its very first flight. In fact, the most demanding phase of the entire manufacturing process is only just beginning. Before a single drop of fuel is loaded into the airplane, every major system must prove that it works exactly as designed. Engineers begin a long series of inspections, checking thousands of individual components one by one. Every electrical connection, hydraulic line, fuel pipe, flight computer, and control surface is carefully tested. A modern passenger aircraft contains millions of individual parts, and every critical system must perform perfectly before the airplane is allowed to leave the factory. Next comes the first power-up. For the first time, electricity flows through the aircraft. The cockpit screens come to life. Computers begin communicating with each other, and hundreds of onboard systems start running their automatic self-checks. Engineers monitor every result from dedicated control stations, looking for even the smallest warning or unexpected reading. If something does not perform exactly as expected, the issue is corrected immediately before testing continues. One of the most important inspections focuses on the flight controls. Although pilots move only a small control wheel or side controls inside the cockpit, those movements travel through advanced electronic systems to operate large control surfaces on the wings and tail. Engineers slowly test the elevators, rudder, flaps, spoilers, and ailerons while computers measure every movement. Even a tiny difference from the required position could affect the aircraft's handling in the air. Fuel system testing follows next. Thousands of gallons of fuel will eventually be carried inside the wings, so every tank, valve, and pipeline must be completely sealed. Engineers perform pressure tests to detect even the smallest leak. At the same time, hydraulic systems are tested under operating pressure because they control many of the aircraft's most important functions, including steering, landing gear, and braking. After the internal systems pass inspection, attention moves outside. The landing gear is checked repeatedly as engineers extend and retract it using hydraulic power. Powerful brakes are tested, steering systems are verified, and the aircraft is prepared for one of the most exciting moments inside the factory, the engine start. For the first time, the massive jet engines are brought to life. As they begin spinning, technicians carefully monitor temperature, pressure, vibration, fuel flow, and hundreds of other performance measurements. Even though the engines have already been tested separately before arriving at the factory, this is the first time they operate as part of the completed airplane. Every sound, every reading, and every response is recorded and compared against strict engineering standards. With engine testing complete, the aircraft leaves the assembly building for the first time. Slowly, the finished Dreamliner rolls into daylight, where final inspections continue. For many workers, this is a proud moment because they finally see years of engineering and manufacturing come together as a complete airplane. The next stage is taxi testing. Pilots carefully guide the aircraft along the airport taxiways while checking steering, braking, acceleration, and communication systems. At higher speeds, engineers collect valuable information about how the aircraft behaves on the ground. Every test brings the airplane one step closer to flight. Then comes the moment everyone has been waiting for, the maiden flight. Test pilots smoothly advance the throttles as the engines produce enormous thrust. Within seconds, the Dreamliner accelerates down the runway. As speed builds, the nose gently lifts, and for the very first time, the aircraft leaves the ground under its own power. Years of design, manufacturing, inspection, and testing finally lead to this single, unforgettable moment. But the first flight is not simply a celebration. It is a flying laboratory. During several hours in the air, engineers monitor thousands of measurements transmitted directly from the aircraft. Pilots intentionally test different flight conditions, including climbs, descents, turns, autopilot operation, navigation systems, engine performance, and emergency procedures. Every result helps confirm that the aircraft performs exactly as expected. Once flight testing is complete, the airplane returns to the factory for another detailed inspection. Engineers carefully examine the aircraft again, looking for anything that may need adjustment after its first flight. Small software updates, system calibrations, or minor corrections are completed before the aircraft is approved for delivery. Finally, the cabin receives its finishing touches. Seats, carpets, emergency equipment, catering supplies, and airline-specific features are installed according to each customer's requirements. Every reading light, entertainment screen, overhead bin, and passenger seat is checked before the aircraft is cleaned and prepared for delivery. What makes the Boeing 787 truly remarkable is not only its size or price. It represents decades of innovation in materials, aerodynamics, manufacturing, and digital technology. Its lightweight composite structure allows airlines to reduce fuel consumption, while advanced systems improve reliability and passenger comfort. Behind every completed aircraft stands the work of thousands of engineers, technicians, designers, pilots, and factory workers spread across the world. Each Dreamliner that leaves the factory carries far more than passengers. It carries millions of engineering decisions, years of research, thousands of hours of skilled labor, and the combined expertise of one of the most advanced manufacturing networks ever created. From carbon fiber production to final flight testing, every step reflects the extraordinary precision required to build one of the world's most sophisticated passenger airplanes. The next time you see a Boeing 787 climbing into the sky, remember that it did not appear overnight. It traveled an incredible journey through one of the largest airplane factories on Earth, where thousands of people transformed separate parts into a machine capable of connecting continents. It is a reminder of what modern engineering can achieve when innovation, precision, and teamwork come together. Now we want to hear from you. Which part of the Boeing 787 manufacturing process impressed you the most? The giant carbon fiber wings, the advanced engines, the final assembly, or the incredible flight testing? Tell us your answer in the comments below. If you enjoyed this documentary, don't forget to like the video, subscribe for more behind-the-scenes factory tours and engineering stories, and share this video with someone who loves aviation technology and amazing manufacturing. Thanks for watching, and we'll see you in the next documentary.